Today is Friday, October 19th, 2018, and tonight we have a $1 billion jackpot for the Mega Millions. I was thinking about this, getting that much money in one lump sum payment. I think it'd be a lot to handle for a lot of people who aren't used to having that kind of money. So out of curiosity, I was looking into the different ways that you could take that money, and we have the annuity option, which is your second option, and it's paid out as one immediate payment followed by 29 annual payments. Each payment is 5% bigger than the previous one. And I was wondering, exactly how much would that be? How much would that first payment be? And then each sequential one after that. And it turns out there's actually a formula to figure that out, and I decided to make a video showing people the formula and how to figure out exactly how much you would be getting paid if taxes were involved with this for a $1 billion payout. So to start, I'll say we have $1 billion in the end. It's going to be equal to some number that we're going to get their first initial payment. We'll call that A. And then we're going to add to that A times 1.05, because we're going to get A plus another 5%. And then again, we'll add A times 1.05 squared, because that previous value will again have another 5% added to that, plus so on, all the way until we get to A times 1.05 to the 29th power, because we'll have 30 terms then, this one right here being the first term. And that's the basic formula, but it's a lot of terms to be writing out or entering into a calculator. There's got to be an easy way to figure this out. Turns out there is. So if we let this initial $1 billion, right, we'll call that SN, S sub N, and then A will stay A, and we'll let that 1.05 be called R for rate. Say R is going to be equal to 1.05. And that's all that we'll need for variables. So let's rewrite everything. We'll have S sub N is going to be equal to A plus AR plus AR squared plus all the way until we get to AR to the 29th power. And now if we multiply both sides of this equation by negative R, we'll have a massive cancellation, and it will simplify this formula dramatically. So negative R times Sn is going to be equal to, in multiplying negative R by the other side, we have negative AR plus, actually I won't write that addition symbol because I'm not going to write plus negative. Plus negative is just negative, so then we have negative AR squared plus all the way until we get to, I wrote a plus again, so change that to a negative, negative AR to the 29th, and then we're going to multiply this 29th one, this last term, by R again, so we'll have negative AR to the 30th power. And then what we can do is we can add these two terms together right here, and what we are left with is we have Sn minus R times Sn is going to be equal to, and we have positive AR, negative AR, positive AR squared, negative AR squared. All these terms cancel, this term cancels, and that term cancels, and all that we're left with is this and this right here. So we have A minus A times R to the 30th power. And as you can see, this simplified very nicely, and we can do a couple more simplifications. So then we can have Sn times 1 minus R is going to be equal to A times 1 minus R to the 30th power. And what we want to solve for is A, because we want to know what the first term is, our first initial payment, and then we can use A later on to figure out how much our final payment will be, and we can get an idea of what all the payments in between are going to look like when we know the lowest payment and then the highest payment at the end. So solving for A, we have A is going to be equal to, we have Sn, 1 minus R, divided by 1 minus R to the 30th power. And at this point, we can plug everything in, and we can say that A is then going to be equal to the original values up here. We have Sn, which was $1 billion, times 1 minus the rate, which is 1.05, all divided by 1 minus 1.05 to the 30th power. And this is going to give us the final answer for A for our initial payment. And to figure this out, I'm going to use MATLAB, which I have open on my computer already. So we'll enter this in. We have 1 billion times parentheses 1 minus 1.05, and we'll divide that by 1 minus 1.05 to the 30th power. So we have 1.5051 times 10 to the 7th power. So in other words, we move that decimal point 7 places to the right, and what we're left with is 15051, and that's 4, then 5, 6, 7. We'll bring that decimal point over. And to make sure that this makes sense, what I'll do is this. I'll multiply that number right there by 30 and see what we get. And what we have here is 451,530,000, which makes sense. That's only half of a billion, or nearly half of a billion, right? That's because the first payment is small, and each sequential payment gains another 5% from the previous one. So after 30 payments of that, what we'll have is this initial payment right here, which we said was A from the formula. And if we go up back over here in the formula to the very last term, we have A times 1.05 to the 29th. So we'll see what the last payment will be. Make sure that all this makes sense. So that's going to be A, and then multiply that times 1.05 raised to the 29th power in this case, because it's the original formula. And that's going to give us 61,952,000. So I'll just write that out again. We have 61952 plus another 3 zeros, and that gives us 61,952,000. And to see that that makes sense, I will multiply that times 30. We'll see how far over $1 billion we get. So if we were to get that last final largest payment 30 times, then we'd be getting, that's 1.8586 billion. Or in other words, we'll write that down just so that it makes sense over here. So we have 18586, and then we have 9 minus 4, so 5 more zeros, and that gives us 1,858,000. I mean, yeah, 1,858,600,000. And that makes sense, because if I move this over, right, I didn't write down the other value that we got up here, 451 million right there, so I'll write that down too, just so this makes sense. 451,530,000. All right. So then we have 451,530,000, and then 1.86 billion approximately, and that's right on both sides of $1 billion. So intuitively, it makes sense. The numbers seem to work out. So if there were no taxes involved, and you got exactly $1 billion in annuity payments spread out over 30 years with a 5% increase after that initial first payment, the first payment would be 51,000 the first year, all the way up until your final 30th payment of 61,952,000. So that concludes this video. Good luck if you're playing. If you have any other videos you'd like me to make, feel free to leave a request in the comment section. Thank you for watching.